same book, Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, a muon has a mass of 106 million electron volt over c square, where c is the speed of light, 3 into 10 raised to the power 8 meter per second. Okay, calculate the speed, momentum and total energy of a 200 million electron volt muon. Okay, quite simple. As in previous problems, this is just a continuation of our previous problems, in which we are finding the speed, momentum, etc. Okay, before starting its solution in a formal manner, we will have to go through a few slides. Okay, these slides will provide a guideline for the solution of this problem. Okay, first slide is about Lorentz factor. Okay, because this slide has been taken into consideration several times in our previous problems, so for the time being we are going to skip this one. Okay, next slide is about total energy of a particle, E equal to k plus mc square, alternatively becoming equal to mc square over under root 1 minus v square over c square, this alternatively becoming equal to Lorentz factor gamma into mc square. This has also been taken sometimes during previous problems. Next snapshot is about relativistic momentum, P equal to Lorentz factor gamma into mv. Okay, where m is the rest mass of particle and v is the velocity of particle, while gamma is Lorentz factor relating rest frame of particle and frame of observer. Next, now we are going to start our problem in a formal manner. Okay, using this expression that total energy, using this expression that total energy is equal to kinetic energy plus rest energy, that is E equal to K plus mc square, where capital K is the kinetic energy. Sometimes we can also denote this energy as capital E with K as a subscript of E. Okay, so E equal to K plus mc square. Here kinetic energy is given as 200 million electron volt, while rest energy is given as 106 million electron volt. Okay, we once again go to solution to problem. Okay, mass this and total and 200 million electron volt, this is kinetic energy, this is rest energy. Okay, one is kinetic energy and one is rest energy. Okay, rest energy is 106 while kinetic energy is 200 million electron volt. Okay, both these energies will add to give total energy. So total energy will become equal to 200 plus 106 equal to 306 million electron volt. Now we know that total energy E is equal to Lorentz factor gamma into mc square, from where we have taken this expression. We go to slides. Okay, this E equal to k plus mc square equal to mc square over under root 1 minus v square over c square, alternatively becoming equal to gamma mc square. Okay, so E is equal to gamma mc square. E is equal to gamma mc square. Okay, this implies that in place of E we have used its value, that is 306 million electron volt equal to, however yet we have not disturbed Lorentz factor gamma because we have to find this factor, Lorentz factor. Okay, so value of E 306 million electron volt, this becomes equal to gamma into 106 million electron volt. From here we get a value of Lorentz factor gamma which becomes equal to 2.89. Okay, we know that Lorentz factor gamma is just a number, it has no units. Okay, now we know that Lorentz factor gamma is equal to 1 over 1 minus u square over c square, or alternatively equal to 1 over 1 minus 1 over under root 1 minus beta square. Okay, because dear students, this factor, that is u over c, is called speed parameter and is sometimes denoted by beta. Okay, beta stands for speed parameter, beta or u over c stands for speed parameter. Okay, so there is no difference whether we use u over c or beta. Okay, this implies that 1 minus beta square is equal to 1 over gamma square. What we have done? We have shifted 1 minus beta square under root on other side of equality. Okay, so from denominator it has been shifted to a numerator. Moreover, Lorentz factor gamma, after having been shifted to other side of equality, becomes in the denominator from a numerator, and in the next step we have taken square of both sides. By taking square on both sides, under root of 1 minus beta square vanishes, disappears, and we get 1 minus beta square equal to 1 over gamma square. This implies that beta becomes equal to 1 minus 1 over gamma square. Okay, what we have done, we have shifted beta square on other side of equality, and hence 1 over gamma square becomes on other side of equality as minus. Okay, so 1 minus 1 over gamma square becomes equal to beta square, and after this we will take under root on both sides, and then beta becomes equal to under root 1 minus 1 over gamma square. We have found the value of gamma, that is gamma is equal to gamma has become equal to 2.89. Okay, when we, this is almost equal to 3. So simply when we will take its square, it will become about in between 8 and 9. Okay, so gamma is equal to 2.89 while gamma square becomes equal to 8.35. Okay, as I had said that value of gamma is nearly about 3, so its square will be nearly about 9, slightly less than 9, so it is 8.35. so our beta becomes equal to 1 minus 0.12, from where this 0.12 has become, when we divide 8.35 by 1, then we get 0.12. Okay, and when we subtract 0.12 from 1, we get 0.88 under root. Okay, and when we take under root of 0.88, it becomes 0.94. Okay, this is the value of beta. Beta has become equal to 0.94, and we know that beta is equal to V over C. Okay, so in place of beta we have used its alternate value, that is V over C. So V over C has become equal to 0.94. This implies that V becomes equal to 0.94 C. Okay, now we know that momentum, relativistic momentum, is equal to Lorentz factor gamma into mass into velocity. Okay, so gamma, we have found the value of gamma as 2.89 into, in place of m, we have used its alternate value, that is 106 million electron volt over c square, into, in place of v, we have used its alternate value, that is 0.94 c, which we have found in the previous step. So from here one c will be cancelled, and our relativistic momentum P will become equal to 287.96 million electron volt over C, where C is the speed of light. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.